Welcome back to GearWire.com Studios. Bob DeFazio here again. Right now, I'm sitting next to the new PreSonus ADL 600 twin-channel tube preamp. So the first important knob here is your input selector, and I have it set to instrument right now so you can hear bass guitar. And we could also switch it to line level, at which point we would no longer hear my guitar. Or we could go to one of four microphone impedance levels, and I would highly recommend fooling with these. It's not common to have the input impedance of your microphone sort of memorized, and there's no math or science that's necessary to use this knob properly. It's basically just an artistic choice. So it's meant to be fooled with. If you put up an SM57, try it at all four impedances. If you put up a U87, try it at all four different impedances. It's all a big experiment, and this gives you the option of cranking out different levels from your microphones, which is great. So we're going to go back to instrument, where you can hear my bass guitar. Now the gain control is with two different knobs here. You've got a strict gain control knob, which is fixed at particular decibels. So you have 30, 35, 40, 45, 50 decibel settings. And then next to it you have a fine tune, otherwise known as a trim pot. Pot standing for a potentiometer. So you can get sort of the rough input gain setting here and then fine tune that input setting with the trim knob. And that works for all three input devices. Normally when you see trim knob, that means just line level input. But this trim knob functions on your instrument level input, mic level input, and line level input. Now, obviously, you need phantom power. Phantom power is 48 volts of current that is added to the mic signal, the mic cable that's coming out of the back of this preamp, and it powers condenser microphones. So everyone has to have that on their preamp nowadays. Next door is a polarity reverse. Polarity reverse means it's going to invert the phase of your signal. Now this would only be necessary if you were using more than one signal source to record an instrument. So a premium example would be if I were to take my bass and send it DI into one of these preamps, which means to directly inject it into one of these preamps, and then I was also going to use a microphone on the other channel, which would be recording the output of the bass guitar amplifier. Now it may well be that those two signals don't arrive at this preamp at the same time. The direct injection signal is going to get there first, and then the signal from the microphone, because the microphone path has two transductions in it. There's the transduction at the speaker cabinet and then another transduction at the microphone itself. So if I were plugging in a DI and a microphone for the same bass guitar, I would most certainly flip this polarity switch and listen to see if when I flip the switch I get greater combination of the two signals. So what you want is for your two signals to be constructively interfering, which means that when you turn them both up, you get more volume. If you were to turn one up and then the other and the volume decreased, you would certainly know that those two signals are out of phase. So you flip this switch basically until you hear the most noise, or sound, excuse me. Then there's a 20 decibel attenuation pad. Attenuation is the opposite of amplification. It is going to knock down the signal strength of this preamp by 20 decibels. What that accounts for is an extraordinarily loud sound source. So if you were to put an SM57 microphone on a snare drum, the microphone itself is not going to overload, but it is going to create an incredibly hot signal for this device to deal with. So if you've found your gain is all the way down at 30 decibels and you're still clipping, well then you'd have to hit this pad and bring it up a little bit more. So that's one of the first things I would work with for intense sounds like kick drums, guitar amps, things that generally rock. Then next door you have a high-pass filter, HPF. High pass, same thing as saying low cut. So when you flick this switch, there's going to be some sort of removal of bass frequencies. Where? What frequency? Well, that's all described here on this high-pass filter knob. So this switch over here is related to this knob over here. I don't know that you would automatically associate these two things to be controlled together, but in fact they are. So here what I'm going to do is I'm going to lay down on the E string on my bass guitar. I'm going to create some low, low tones. I'm going to take my filter off, and and you'll be hearing an unfiltered low E string on a guitar. Now I'm going to kick the filter in at 40 Hertz. I don't think you'll hear any difference because you're probably at a computer. Now I'll move it up to 80 Hertz. You might start hearing a difference. Signal should sound thinner. Say that 10 times fast. All right, now I'll move it up to 120 Hertz. This means that I am going to start attenuating at 120 Hertz and remove all frequencies below 120 Hertz at a particular slope. So there'll be probably no 40 Hertz, no 60 Hertz, no 80 Hertz. And let's hear what that sounds like. So here's unfiltered and filtered at 120 Hertz. Now, why in the heck would anyone do that? Well, you wouldn't do that with a bass guitar. It just so happens to be a particularly good example of an instrument that will create a lot of bass. But you use this high-pass filter to counteract what's known as the proximity effect. The proximity effect is common to all directional microphones. So an omnidirectional microphone does not have a proximity effect. But a cardioid mic, hypercardioid, anything like that, those microphones exhibit what's called the proximity effect. As you move a unidirectional microphone closer to the sound source within a foot, every inch you move closer to the sound source, you get an increase in bass frequency response. So if you put an SM57 microphone smack up on the head of a snare drum, you're going to get a deeper tone. It's going to create more bass. And as you move the microphone further away from the source, you're going to get a thinner sound, less and less bass. What do you want in a preamp? Well, you want as much flexibility as humanly possible, like you'd want with any good microphone. This preamp is extremely flexible. It has variable inputs, so you can have mic, line, or instrument level inputs. It has variable impedance settings for your microphone, so you can fool around with 1500 ohms or all the other ohms that they have here, 900, 300 ohms you can fool with. In addition, you have an attenuation pad for when your microphones are next to extraordinarily loud sounds, and you have a high-pass filter. But not just any high-pass filter, you have a frequency-selectable high-pass filter, and we're going to talk about that in a minute. But I would say that this has good metering options because it's VU and peak meter. It's got variable everything.